Hey everybody, this is Larry. This is me going with Q4 of the biweekly contest 98, handling some queries after update. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this prompt. So let me start by first saying that no, you will not need to know this for interviews. Maybe if you, maybe if you are in China or India and you have a crazy OA like online assessment or something like this. But even then, uh, like it's one of those things that comes up so rarely that like you, like the analogy that I always try to make is that if you could be really good at, let's say there are 10 topics, right? There are more than that, but let's say there's 10. I would rather be really strong for five types of problems versus being average at 10, right? Because then you could really impress people with the five that you're really strong at, and versus like being average at whatever they give it to you, right? That's my game theory. Take it as you will. That said, it's not, and that assumes everything is equally distributed, and you get a random problem that is of one of the 10 types, right? This problem is of one of those types that comes up maybe 1 in 1,000, even if you do see it that way, or if the interviewer is having a really weird day, or if the interviewer, knows that if the interviewer knows that you've been sabotaging them for some reason or something, and really has a reason to hate you, then you'll see this problem maybe, right? But other than like extraordinary scenarios, I think even if, I mean, look, things may change. This is the year 2023. I've been saying it for maybe 5 years for this type of problem, but maybe in 2030 or something, maybe Larry is retired, and this is a common thing. But and if you're watching it in the future, you're gonna be like, ah, Larry is so whatever. Just want the year is 2023, and no, you're not gonna need to know this. And maybe some of it, though, of course, is just me coping because I didn't know how to solve this per se. So if that makes you feel any better, or not even that I didn't know how to solve it, it's just that I would not have the knowledge to solve it, right? Because it's like, it's not, because at a certain point, it's not about problem solving, it's just about knowledge thing. And this is kind of falling more into the knowledge thing where either you know it or you don't, kind of, right? And I say kind of because with a caveat is that I know enough of it to be able to learn it during the contest, and this video is going to be that explanation. And this is a long video because I try to show you how I come up with it during the contest as well, right? So you could see how Larry solves a problem live, and I don't know why I'm referring to myself in third person like a strange weirdo, but you could see me solve this problem live during the contest, right? And I think a lot of the times maybe it's helpful, maybe it's not, because to be frank, sometimes I'm just like I know it, and I'm not good enough to be able to talk and go really fast as I can while coding it in. But this one I struggle with a lot of different random things because I am learning it for the first time. So definitely, if you're curious how someone of my skill level, whether you consider it good or not, that's up to you. But this is a sort of a live solve from someone of my skill level, right? Of someone whom or how I learn about things during the contest, right? And so, and I say kind of only because I have some foundations for this, right? So I'm not coming from nothing, but I am. So I'm not coming from nothing, but it is something that I have some basic idea of, and I have to learn the rest of it, right? So okay, without a little bit of spoiler, but that's basically the context and the explanation about this. With that being said, I actually took about an hour for this problem, and with 4 penalties. And therefore, I think I was like top 10 or very close after the first 3 problems. But as you can see, my rank dropped a lot, but I don't care about the rank. I would say that despite all that, right, I'm really proud of how I solved this problem, because it was very new to me, to a degree. I mean, or you'll see why in a second. It's not just the data structure. The data structure is, to be frank, the first time I ever solved this data structure in my life, or this variation of this data structure. So with that being said, like, the first time you do anything, you're going to make a lot of mistakes. And for this particular problem, it's not just about adapting it. It's not like a plug and play and then now you have the answer, right? I actually have to adapt it to fit the problem. So that's why I have 4 wrong answers. But I'm also, like I said, very proud of it because I am able to, well, one is that I'm able to figure it out by myself without too much cheating. Depends on how you want to consider cheating. Like I did learn about the data structure more, and maybe I'm saying it in a non-spoiler way. Okay, here's a little bit of spoiler. It's segment tree with lazy propagation. On you can maybe also even say that as a segment tree with range queries and range sum, something like this, right? So yeah, so with that, and I knew a little bit of a segment tree. I didn't know how to do lazy propagation. I didn't know how it works. I know the only thing that I kind of have an idea about is that I do know how segment trees work, in the sense that I know how trees work, but I didn't, like, I knew conceptually what lazy propagation is, but I didn't even really learn about it during the I learned about it, but from reading like 5 lines of code. Like it wasn't me like reading the whole story about it, right? It's me reading it from like 10 lines of code, 5 to 10 lines of code of like, okay, this is lazy propagation. I'm like, what? And then try to almost reverse engineer the answer from that. And that's why I'm proud. So then the question is, maybe at this point, if you're still watching and not just like skip ahead or skip to another video, is if this problem was so hard, why was I 512, right? And the short answer is, well, one is that because I have 4 wrong answers, that increases the penalties a lot. But the other thing is that apparently this answer or the solution is Googleable. So the theory that people on my Discord had is that it's Googleable, and so and there's a link from a dubious website, say, that actually has basically 90%. I want to say I didn't actually look at the website, so I don't know if this is true, but about 90% of the solution, or at least something like this, right? So that's why a lot of people got it. Yeah, so that's why a lot of people got it. But so with all these things in mind, I'm still very proud of what I did with this one. Okay, so that's all the caveat, all the introduction, and I've done 8 minutes. I haven't even talked about the problem yet. So basically, let me go over how I thought about this problem during the contest and how I came to that, right? So just to be clear, I didn't realize that I need lazy propagation until later on. I didn't even think I needed sigtree until later on. So I will explain my thought process going from opening the problem and then going to sigtree and lazy propagation. Because I feel like for me, that is the more interesting part, right? Like, you could Google the other solutions or whatever, and maybe it'll give you a better understanding. But for me, it's about arriving at the solution and maybe thinking about it, right? So the first thing that I thought about is that I saw that there's 3 types of queries. I look at constraints really quickly. N is 10 to the 5th and Q is 10 to the 5th. So that means that for every query, we can do at most log n or something like this, right? Because otherwise it's going to be too slow. Even log n, Leetcode, Python, there are a lot of constants and stuff like this. I worried about it anyway. But then the second part, it means that I have to be, that's the first part, right? I have to be really good at this or really fast about solving this, right? Yeah. And then, okay. So I thought about this for a while. And kind of some of this, I looked at it from this thing. But to be honest, this problem has a lot of reading or a lot of interpretationing, right? Interpreting? Yeah. There's a lot of interpreting about this problem. So it's kind of hard in that way. The first thing is noticing that Q3 is just sum of everything, right? Okay, so it's sum of everything, that's fine. Q2 is basically, there's this like multiplication weirdness, but what it actually is saying is that count the number of ones, because nums1 is just an array of 1 and zeros. So, and you basically, query of type 1, just flip zeros to ones and ones to zeros, right? For me, that basically is saying that like my first idea from this from query one is an XOR prefix sum, right? Like basically, you have a range thing. You have a you have zeros and ones dotted throughout, and then for every query, you want to flip a range from 0 to 1, and then and the idea from that is prefix sum, which I'm not gonna go over it that deeply, but it's a problem that hierarchy, or not hierarchy, a problem archetype that has come up in Leetcode a lot. In real life or in interviews, not as much as far as I know, or as far as my understanding, but that is the that is basically what I was thinking for this one, right? And for this one, it the way that it's phrased, like I said, it looks like a multiplication, but what it really is saying, because p doesn't change for any index, what it's saying is that nums2 is just so nums2 just add basically a p. Like you could replace this with an if statement almost, right? You could replace this with an if statement of basically if num sub 1 of I is equal to 1, num sub 2 sub I add to p, something like this, right? So that's basically the idea of what I think about when I saw p2 or query 2, and then it took me a little bit. You could watch it in the live portion. It took me a little bit, but then you could see that I was like, oh wait, if you combine Q2 and Q3, you actually don't need to know num sub 2 other than the initial component, which I missed in the beginning anyway. But other than nums 2, you actually do not need, like the initial sum, you actually do not need to know how it evolves, because all you have to do is sum it, right? And basically now Q2 becomes count the number of ones, because now Q3 is summing it. It just becomes, okay, how many times is nums 1 1, right? So then now the problem becomes how many ones are there in nums 1 after every type 1 query, and you flip. So basically you have like so my idea at this point, my understanding and interpretation is that you have some 10001, whatever, maybe even 9, but yeah, and then you basically, okay, how many ones is there? There's 10 ones, right? And then so whenever we get type 2, and with some p, then this turns into, okay, now the 10 ones in the entire way, so then it's just 10 times p. And then you add it to the sum, and then type 3 just return the sum, right? And that's basically the idea. And then type 1 queries, you just flip or toggle, if you will, some range, right? So it could be something like this, for example. You go 1 0, I don't know, you just toggle the things in between, and then now you have a new number of ones, something like this, right? Actually, this is still 10, but so I messed up on the toggling, but you get the idea, right? So this is toggling some ones. So I was stuck a little bit on the prefix sum idea a little bit. Sorry, I'm moving the screen a little bit much. So I was stuck a little bit on the prefix sum, on the idea a little bit, and then I go, I literally go, But this is probably a sig tree. I was trying to figure out if I could do it with binary index tree, but and I have some of these things coded up, but I just was like, no, that's not it, because of the way that. I look at the binary index tree code. I was like, okay, the way that you propagate things up in a binary index tree, just not going to cut it. So then I was like, okay, fine. It's a segment tree in which we have to do XOR on each element, right? So okay. So then I'm not gonna lie. At this point, I did have a segment tree code typed coded up. This is just. I think this was because. I think there was another Leetcode problem with segment tree during a contest once, so I was like, okay, let me just code this up, and let me just code this up. You could watch it live. I basically paste this in there, but it's not what it looks like now, right? It's just a very vanilla segment tree. I think the original code that I have was and also let me just actually give you a link real quick. I will also put this in the. I mean, this is not where I got my code because I have my own. I like to code my own things so that because I consider it the best way to learn about it, right? If like I don't believe in copying other people's template, that's silly. Or like maybe that's just my opinion, my old school opinion. You could do whatever you like. And also honestly, if I could use it as a black box for this problem, I would have. But yeah. So definitely check this out, or you could just Google segment trees probably, right? It's yeah, I mean, I don't think I talked about this yet, and I'm not going to go over it. Segment tree is, I wouldn't say it's a hard topic, but it's a long topic. So I'm not going to go over it with the scope of this problem just because it would take all day. And also, to be frank, I don't think I understand it to a level in which I can teach it in a in-depth and understandable way. Maybe I am better after this contest, but just to be frank, right? I don't know that I'm qualified to do it. And just to kind of give you a little bit of a context on a couple of things, right? Is that this is probably like, I don't know, the fourth time maybe, under 10 for sure, probably under 5 times I've ever used segment tree in my life. You can take it as you will. You can interpret it in a number of ways. You could say Larry's lazy, Larry's a little bit old, and because we didn't have segment trees back then, for sure, we didn't have it back then, or at least not for competitive. But another way to interpret it is maybe that, look, if Larry doesn't need it, what are the odds that you need it, right? Other than silly Leetcode competitive problems. You could take it that way. That's how I prefer to think about it. That said, it's up to you, right? Like at the end of the day, it's just about learning and having fun. And for me, I am learning because I'm having fun, but I'm not. I wouldn't say that I know this algorithm because of interviews or something. It's just another tool. Yeah. So I'm not going to go over the code too deeply. Let's think about this as a black box first. So the segment tree I actually understand. I wouldn't say very well. Every time I use it, it feels like I haven't used it in a while. So it's always very rusty because it really doesn't come up that much. Like I said, like one hand count number of times I've used it. You could probably look for all the videos, and because I think I've only used segment tree in Leetcode. I don't think I've ever used another contest. Maybe that's not true. Maybe I did in Codeforce once or twice. I don't know, but in any case, like I don't. Yeah, it's not very many, right? So I always feel rusty every time I use it that I get the indexes wrong, right? But let's just say we have a perfect segment tree first, right? With no whatever about it. Then let's go over this code, right? Basically, here I update. Let's say update index to 1, and the way that I do my segment tree is 1 index. That's why there's a +1 in all these random places. Yeah, right. And then type 1, as we said, we update a range from L1 to R1, and then for type 2, we just count the number of things. And then this is L because this is the L, but you can also maybe say P is equal to L, and then, because P is the parameter that's in the thing. And then type 3 is just, put in the total, right? So this part we already kind of went over. Let me know if you have questions here, because I think, this is actually really straightforward now that, you made some of the observation reductions, right? And then, but basically, so the part that I did not know, and this part is less interesting now, maybe, I don't know. But basically the part that I did not know, so the part that I didn't know is this thing about lazy propagation. So not gonna lie, I don't I know segment tree in idea, but there are a lot of things about it that I don't know, right? With respect to there's just a lot of not weird, but weird to me because it's new to me. There are not a lot of ways to use seg trees, And for this particular one, the keyword that you may be looking for if you're Googling is range update and range sum. So that's basically what I would say, right? Oh, and here is, let me add this for toggle indexes between L and R inclusive, right? Yeah, let me also just make this count. Yeah, I don't know anything about lazy propagation. And part of that is because you can think about this as a range update segment tree with a range sum segment tree, right? So that's basically the idea. And that in itself is not that bad. I'm going to show you the modification that I did. But it turns out that for range updates, you have to do something called lazy propagation. And I actually didn't really know what lazy propagation is. Or, I mean, the thing is, right, lazy propagation as a term, as like, not necessarily relating to search trees, but just like in general, lazy propagation is a term that comes up actually quite a bit and often in with respect to just competitive programming, but also algorithms and in general. So I didn't know what segment tree lazy propagation is, but I didn't know what lazy propagation is in general, and the idea about it, right, is basically is that you only do updates when you are absolutely needed to do the update, and therefore there's some usually amortized cost benefit to it because you're not doing it on every update, and something to be updated more than once. And the canonical way of, like I said, the basic sig tree, I don't know if this is basic, is going, or maybe the basic is the one that is that operates on either adding or either add. So if you, there are a couple of sig trees, like, the operation is, you want to add, subtract some numbers, give me some of a range, right? There was also add subtract some numbers, give me max of a range, something like this. So there are a lot of variations. I could draw them more, but the ones that is this one is like the one that I drew from is that, okay, we want to add a number to a range, give me sum of a range, right? And the idea here is that except for, so this is the quote unquote basic one that we think about, or that I thought about, but then we have to change it so that instead of adding a number, is XOR or flip, if you want to call it that, or toggle a number to a range, give me sum of a range, right? So that's basically the idea that we needed to solve this problem using an XOR segment tree, kind of, right? And then we'll go over it. So what does this mean? This means, and this is kind of hard to kind of explain without basic knowledge of the original segment tree. So this presumes that you know how segment trees work in general. But the core idea really, I mean, you can get fancy with a lot of these things, and I'm not going to, because I don't know that I'm competent enough to be fancy. But a lot of it is just about divide and conquer, right? It is in the name, it is a tree, and then you kind of think about, like, basically you have these components, you have some of these components, and then you try to, the idea is that you break it down in a good way, and then you merge it back in a good way, right? So that's, and that the higher node will contain the information that you need, so you don't always have to go to the bottom node, which gives you that complexity. I know, I'm hand waving a lot of stuff here with SegTree. Like I said, SegTree is really long, so I'm not going over it, but that's basically, how I think about these things. That's how I structure this knowledge in my mind, so that I can kind of, reread the code. This is the context, right? So there are two, build is just building from scratch. You can do it in a number of ways, but so there are two main functions. One is an update function, and then the other is a count function, which is, you could also say, sum function, right? So for the update function, yeah, basically the thing that I changed is now, and this took me a while. You could actually watch me solve it during the contest, and you'll see me make the realization and the progression and the learnings every step of the way, which I hope is interesting, because this is something that, like, yeah, a lot of people did it faster, but to be frank, did they learn the way that I did? I don't know. So I'm very proud of it. I mean, obviously, some people actually just already know it, and those people are very smart and etc. But the people who just Googled it and pasted it, can they say that they learned it? I don't know. But yeah. So this part is going to be the divide and conquer. I'm not going to go over it that much. But the idea is that in the segment tree node, right? And I'm not going to go over what that means, but in a node, I contain two things, say. Each node contains two things, right? So given this node, it contains the number of ones in this subtree, right? And also, and then, so that part, hopefully that makes sense, because let's just say you have a static tree that isn't a seg tree, then if you have all these nodes that just is equal to the sum of its components, right? Which is how we get this thing, because here, and I annotated, the update is just update recursively, so I'm not going to go over this part, but this part means that update this node to be the sum of the subtrees after they update in the above. So after we update the value of these two, and you can maybe make them return, maybe, I guess. Yeah, this tree is equal to these two things, right? Yeah. And so that's how you would do it for so let me go over the non-lazy portion first, right? So the other thing is the count, and the count for this part is also the same, right? So same idea, rather that the number of, okay, so here we return the number of ones in this subtree. Here we go, okay, well, if we don't have the answer in a node, then this is the number of ones in the left subtree plus the number of ones in the right subtree, right? Or right subtree, subseg tree, whatever the vocabulary is. I don't know that much about a seg tree to even know the right vocabulary. So if I'm using the words wrong, let me know in the comments. But I'm trying my best. Okay, right. So this part makes sense. But the idea about lazy propagation. So right now, in theory, we can already solve the problem without lazy propagation. It'll be correct, except for that it'll be too slow, right? Yeah, it'll be too slow because, yeah, I mean, it's just because you have to update a lot of things for this update, right? So the idea here now is about this idea of a mark, which is what I'm doing, the other thing, right? Which is that this the children of this subtree needs to be propagated. Propagated? Did I spelled that right? I don't know. Pretend I spelled it correctly. Actually, that annoys. That nags at me. Let me see. Propagated. Propagated. Anyway, what this means that if we go to the children of this thing, then we need we want to set it to be propagated next, right? Oh, let me actually also go back a little bit, right? So this part I think is understandable. This part is understandable, right? So the thing is that because we're doing XOR, and this actually took me a couple of minutes as well. Like I said, I'm solving this one first time, and I'm like learning segment tree while solving this, right? So yeah. So basically I was like, okay. And if you saw the first first try that I did something like as you go to this, right? Because for me, it's just in my mind initially, I thought, okay, the ith element we need to flip it once, right? And that's good. But then I was like, no, you don't understand, Larry. Basically, the number of ones in the subtree if we flip everything inside, then oh wait, there's a toggle. Yeah, there's for example, if there's 7 numbers in this range and the 3 of them are ones and 4 of them are zeros, if you flip them, that's basically it, right? It goes from 3 to 4 and 3 to 4 and so forth in the subtree. So that's basically how I got this. I even wrote out count because this is basically the number of total numbers in the range, and this just flips half of them, right? Or not half of them, but the number of them that is in number of ones, right? So if whatever values that was before, it's set to that. And everything else is the same. Like I said, this doesn't change. Nothing else changed. So the only thing that changed was here. In order to do lazy propagation for the updates, we basically toggle the children that needs to be propagated. And this actually cost me a wrong answer and some things as well. Is that to be honest, this is kind of a tricky thing for me to understand because, like I said, everything's new to me. But then, and also to be honest, I kind of was hoping that I did not need to do this. So I was kind of just like copy and paste and then submit and YOLO, like it worked for the examples, etc. You could see me do it during the contest as well. So watch that. But basically, the idea here is that, well, if you toggle something twice, what does that mean? That means that you don't have to propagate anymore. So that's basically the idea, and that's basically what I have here. And that's why I did XOR is equal to true, because basically, if it's true, it flips it to false. If it's false, it flips it back to true. That's basically what this does. You go to write is equal to not marked I, but that's the way that I was thinking about it. Because I was still thinking about it as an XOR, so that's why everything has an XOR notation. Okay. So, lazy propagation. So how do we actually do it? Well, there are only 2 times you have to do it. One is before an update and before you do the sum, right? Basically, it's just saying, okay, update m3 sub I for me is what this thing actually what it does is saying is that update the subtrees for me. So basically, this push is saying, okay, propagate to the children if we need to, so that these 2 things will be right? So this is saying propagate to the left, propagate to the right, and then when that's done, we can get the count because we can know that it is right. So that's basically what this lazy propagation is doing. And yeah, and we also do it on update because basically if this doesn't match the range, meaning that we don't have a node for it, then we have to do we have to split it up with a divide and conquer. But update the children first so that we can, so that when we update the children next, they can push that forward. Almost like you're pushing let's say you have a box, you push it to the next square so that when you go to the next step, you can already push that along the way. So that's kind of the idea behind lazy propagation is that, let's say this is the node, you're pushing that work to be done lower, and then you just kind of like in a step function, right? So that's basically kind of the idea and visualization that I had in my mind. Keeping in mind that, again, I'm learning all of this new and all of this from scratch. So yeah. Maybe not like 100% from scratch, but the lazy propagation part with respect to segment tree, I learned from scratch, right? So yeah. And then here, this push is just basically, okay, if this needs to be toggled, if this node needs to be toggled, let's toggle it, right? And this part is actually very hard for me as well, because I think the canonical thing is that you don't need the count, so you don't even have TLTR on like a lot of templates. You just have something like this in the generic segment tree. I was like, how do I get the count from here? Because I was like, oh wait, I need to propagate this idea of flipping a subsegment up to here, but I didn't know how to do it, so I had to kind of come up with this myself. I don't want to sound like I'm being super smart. It's just that, look, I'm actually, like I said, I'm really proud of myself of coming up with this because I had to solve so many problems, sub-problems for this one that, I got 4 wrong answers because each of them is a sub-problem that I have to resolve. But yeah, But as soon as I did this, then I kind of figured it out, right? Basically, if this knows to be toggle, let's toggle it, or let's toggle it, and then by processing the children, right? And then basically, this is now this is very standard divide and conquer stuff. This is basically saying this is the range that the node I stores. So then now this is the middle node, and then so now this is the left side, right? So now this is flipping the left side. This is the same idea as here, which is that, okay, we have a range of, from the left to the middle, inclusive, how many count, and then this basically now we toggle the things to the left, we toggle things to the right. I actually had a typo here that cost me like a wrong answer and like 5 minutes, and I almost lost hope because I had a doctor's appointment right after, actually like it started right at the end of the contest. So I had to leave before the end of the contest, and that was actually very sad. But I fixed this, and then after that I got a hint. So I made some progress. So that's why I kept on going, because I got the wrong answer, but I got wrong answer on a later case. Because after this, I got a hidden example thing, and before that, so the template here was something like, this, right? And the idea here is that the original idea of the lazy propagation in the general sense is that basically if this is marked as true, we want to say, okay, in the future, remember that you have to update for the children, right? From the left children and right children, so that they can update their children in the future. So we set it to true. But because this is an XOR and this is a toggle, I eventually fixed this to XOR it to true, because you can imagine that, let's say that this segment is always scheduled to be toggled. If you toggle it again, like for example, like I'm just going for random numbers, but let's say you're doing 1 to, so this may not actually match up perfectly, but I'm just giving you the idea. But let's say you toggle 1 to 10, right? And then you toggle, say, 5 to 15, and then there's a segment that is 5 to 10. Probably isn't a real segment, but let's just say there is a segment. You could imagine that the first one turned into true, and then the second one turned into false. So if you only update this to true, this would just be wrong, because you would think to only propagate one of the toggles instead of the two of the toggles. So that's basically the idea behind these this component and this component for the left and the right. And then of course, once we finish toggling, we set the current component or the current node to not toggle, and that's why we set to false. You could also maybe think of this as just this thing, but then this is to be true, so that's why I wrote true. But yeah, and at this point, the explanation is 40 minutes long, and this is the explanation without a sick tree, without me explaining the segment tree, which is, so hopefully this, yeah. So that's basically the idea, and that's it. After I fixed this component, so I had one wrong answer here, one wrong answer here. I think I had a couple of wrong answers on just here as well, and maybe some typos. But yeah, I mean, you could watch me solve it during the contest. So let me just show you my code real quick. So this is this is the code part, and this is my segment tree. Let me make this smaller. It's still pretty big. Okay, so this is the top part with the count, build, and push, and then so you can pause and maybe take a look, and then this is the update portion with the push, I guess. So yeah, what is the complexity here, right? To be honest, I'm not super familiar, but basically this is going to be log n for each one, and this is going to be log n. This is also going to be log n, I think, because it may get propagated. Actually, no, it should be, but I think it's either log n or O of 1. Maybe O of 1, just because this is always the top node. But in any case, yeah, and this is O of 1, so it gets dominated by this, which is O of log n. So like I said, I'm not super familiar with it, because this is, maybe I want to say this is actually O of 1, because every time you do it, it just returns this thing. So Yeah, so I think this should be O of 1. Either way, though, it doesn't get dominated. Even if this is log n, it gets dominated by this. So this is just O of q log n. And here, of course, it is n log n, because for each of the numbers, we do an update. So this is n log n plus q log n time. And for space, this is just, I think, I actually don't know. I actually don't. I mean, I think it's just linear, but like, see how noob I am. But I think this is linear because we just have these things. There's something about so this is 4n, 4 times n, which is linear. There's some recursive stuff in here. You could say there's some recursive space, but even then, that's just log n. But that's per query, so because that's a log n, gets dominated by n, so I think it's just n of n space plus q, I suppose, because you have to return the answer. Cool. That's all I have for this one. It's very long, very tiring for me to explain. I mean, I've been going for 40 minutes. I'm really hungry. Look, I mean, if you're still here, leave a comment about how much you love Larry's sex tree code specifically, because I'm just curious how many people are actually still here listening to me. But also, look, there's no way that I could explain everything here. I tried, and it's already been 40 something minutes. So definitely leave a comment here or on my Discord, and I'll try my best. Yeah. Let me know what you think, and you could watch me solve it live in the contest now. To be honest, how am I doing on time? Okay, not yet. Not 10 minutes yet. Okay, no one solved this yet, so that's a thing. So there are 3 types of queries. Flip the rise from 0 to 1 and 1 to 0. Okay, so XOR on type 1 is it? Okay, type 2 P. Well, every I nums of I is equals to, what's nums of 1? Oh, there's 2 arrays. Oh yeah, okay, fine. I didn't actually even notice there were 2 arrays. So P. Okay, so just add P if they're ones, and then 3 is the sum. This is wonky. People already, they haven't updated yet, I guess. And then M is big, queries is big, so if you do naive, it's probably not going to. Any number, and then P is just some number. How do I reconcile? Basically, 1 is just we can't even do a loop on any of these, can we? Oh wait, no. Q2 is different. Q2 is for every index, and then Q3 is also for every index. Okay, I think I missed that. Q1 is an every index, and then Q2 is an every index. Okay. So that means that is there a way to do delay? What are we returning? Yeah, okay. So every time we do delay, right? Okay, so we start with a number, and then every time we get a query 2, we add it to all the ones that contains ones. How do we do? Is there a way to do a finger type thing? Is this a seg tree? Wow, someone got it already. Seg tree for the sum makes sense. I don't know how to do it for the 1 and the 2 though. Compression won't help. You just have 1 0 1 0, and that's still a lot of them. Can I do the flipping in a meaningful way? I mean, we could do prefix sum, but that just won't help enough. I think. Someone got it? Wow, that's impressive actually. Okay. I think I see it. What I see a optimization is that the digits don't matter, it's just the number of 1s and 0s. That's how they get you. Okay, I see it. Wow. That is a gotcha. So you don't actually have to care about it. So 2 and 3 is useless. You just have to do the thing on here and then do a count. How do I do a count? Is it seg tree? I don't know seg tree well enough. Let me look up seg tree. Yeah, I think I got it, but I don't know how to quite do it. I mean, I get the idea, but let me look at. It's been a while. Because we want an XOR seg tree, which is why I don't know this one that well. But I see. I'm just reading this my seg tree code. Let's see. Oh, this is a max seg tree, I think. But we want to count seg tree with the XOR. This is really awkward to kind of do live, but well. And I don't even know if this is right, or the way that I'm writing it is right, rather. Like, I know the idea would be right, maybe. Okay. Good, okay. update is the tough one. Update, we want this to... we don't need a we. I also don't remember how to use this. I have to... I think last time I said I should return a... I think last time I was like, oh yeah, Larry, remember to give yourself examples on how to use it, because I didn't put any helpful things here. But also this thing Leetcode, this may still also time out, so we'll see how this works. I also forget some stuff, like whether search tree is one indexed or not, but oh well. How does this work? I actually don't remember. So the vertex will always be vertex is always 1, and then it's just index. No, this is 1 and then n, and then I is index, I think. I really need to write down how I use this. It's been a while. Okay, fine. Okay, and then now for TLR in queries, basically, yeah, we want to update 11n. Oh, oops, that's not it. Is this right? I think I'm mixing this one. I think I needed the other search tree. I think this template is for, because the update only updates one thing and then you get a query. But what we want is update range. With lazy propagation, I don't have that set up. This is silly. I mean, I know how to do this algorithmically. I don't know how to implement it necessarily. Which is kind of, I don't know, kind of sad. So I also have a doctor's appointment. So I don't know if I can figure this out in time. I'm reading the search tree thing. Do I have the other search tree? No, I don't have the other search tree set up. No. I forget how to do. I'm not too good at the other one. Can I do better? Can I do BIT instead, actually? don't think so. This is so annoying. This is like a library for a lot of people, but not me. I mean, I tried, but not really. I don't know how to lazy propagation, but okay, fine. Yeah, I don't even have this one here. This is actually new to me, so I don't know. Or like, I've never done it in my life. Let me try to see if I can do something about it. Maybe there's a easier solution, I don't know. Do I have to keep track? I think so. I don't think I could do some weird segment intersection thing. I don't know if this is going to be right, but or even fast enough. Okay, I'm just copying some code. Yeah, let's just use this one then. And then, okay, don't know what push means. Tree is kind of very hard to learn during a contest. Did I do this wrong? This part should be okay. I don't know what this mod thing does though, to be honest, but I don't know that this gives me the right answer, but yeah, okay, fine. If t is equal to 1, then we update from two, then we just get a count, right? Oh no, we add the sum, so we get the count. C times the P, which is in this case the L, which is awkward, but okay. And then insert out a pen total, something like this, but probably way wrong. No precision. Did I copy this or something? How did I get this one? What is this I for? Oh, I see. This is now a range. So to the left and I tell you. Then now this, instead of the position which we removed, now the left, and then min of ITM. Forgot to update that. This one. 1 and 0, which is not right. Okay, well. I don't know how. I'm trying to use this as a black box, but this is not working. This is clearly wrong. Oh, this should be index plus 1. Maybe. Maybe still not. And plus 1 maybe? I don't know. Oh, I didn't modify the get function. Okay. Just I know how to do it. Oh, I know the algo, but it's just not right. I wonder if there's a simpler way to do this Exhaustive Tree with lazy propagation. Don't know. Don't think so though. But... And this big int is very efficient. Oh, this is also just wrong. I think this has to be if x is equal to 1. So that is just awkward. Actually, that's even bad. That is wrong though. That means that this is just, you know. This is silly. I mean, this is not a hard problem. I know how to do it for so long. I just don't know the. I don't have the code ready. Well, just in case I missed something weird. Yeah, so it's updating twice at least, which is what we expect. This part of the code I wasn't that dumb about. Also, I forgot to do something. It was just a sum of nums too. So actually, but that's fine. That's an easy fix. How? Why? Tell me why. Why are you not updating? I might have to actually end early on this one, even though I probably could grind for it because I have to go to the doctor. You never give me an easy one on this. Let's see. Oh, this is because the update is a range. It's not just one bit. Okay. Okay. Actually, okay. That part is good. Maybe. I mean, the enter is still wrong, but that's okay. But the second query becomes 111. Okay. Let's see. So after the 1-1, it still is 1. It should be 2 to begin with, at least. So let's see. So at least see if that fixes it. That is 2. So why is it going? So the, oh, this is one index, Larry. Okay. Alright, now to see if it's fast enough. Okay, wrong enter's fine too, I guess. Actually didn't expect that. Well, I mean, I think the algorithm is right, it's just the implementation is wrong in that case, but I miss something about? I don't even know how to do this correctly. Or the last one, it seems like, which means that it added 21. Okay, let's just see. So 679, and then it goes 8917. The right answer is 1053. Why is that? It is because 15 to 21. How does it get the first two right then? Did I mess up something? Maybe I misunderstood the problem. Num sub 1 plus num sub 1 times p. This is just 1 and 0, so that should be still the number of ones. Did I do something silly like this? No, okay, I just want to make sure. No. In this case, I might have to do it here. Nope. Okay. CL. So there's 7 of them, and they're times 21. So that seems right? Did I misunderstood something? So we flip 15 to 21. So we should have 7 of these, right? So then now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Oh, we haven't added anything yet, so the adding is wrong, maybe. Because the total is just so, okay, so that means that my thing is wrong in some way, and the count is definitely wrong, because my sig tree is wrong. My algorithm is okay, because it should have okay, so without changing it as 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So okay, and then update 15 to 21. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So yeah, 21 goes to here. So then it adds 1, so it should be 11, but I get 7 for some reason. Is this right? This is lazy propagation. Push build. Oh, maybe the build is wrong. Because I don't do anything? I don't know. My everything should be just zeros, so it should be okay actually. But poop. Okay, well. So okay. Well, this is definitely not right. Don't know how these things work. Why don't? Why am I getting 7? Oh, actually, I put other stuff too, right? No, this is it. That's actually not great. Is that Leetcode maybe? I changed it because I was copying that code, but okay. Still wrong answer though, so that doesn't fix it, but maybe it's a start. I flipped these 2, but not these 4. And 15 got flipped, so that's good, but I don't know why this is missing these 4. Maybe the XOR doesn't handle well here, or I'm not handling it correctly. But maybe I can do it on XOR. I just assumed that I could with this something, but it may be that these has to be, the propagation is a little bit wrong. Yeah. Can I do it this way? Maybe I can do it with Exhaustive Tree, and I've been just wasting a lot of time on it. So update. Oh, this isn't quite right, is it? Because this updates it for range, and that's not right. No. Okay, I see what I did wrong. No. Okay, but how do I fix this? Can I fix this? I don't know how to fix this actually. Because basically this is just saying that this is equal to R over L plus 1. So this is the the count, right? And then just that's the total count. Count minus this, okay, maybe. Maybe it's off by 1. Nope. What is it? Is this right? Actually, I get the right answer, so let's see. I don't know if this is gonna fix it, but YOLO, right? 3, 5, and then the other thing's right. Alright, let's go. Not surprised because I don't know. There's a lot of adding and flipping. This is actually really annoying. Or annoying to debug rather. Update. Update should be more right. Do I do another mod exhaust stuff here? Okay, I don't think I do it anywhere else, so this should be it. Though I don't know how this. No, this is right, but this is more right. Self-type marked. The propagation is wrong, I think. Where's the propagation? This is the propagation. Because you can't just propagate the change down that way. So basically we have to flip. How? Tell me how. Because it could be propagated twice, right? So this isn't quite right either on the propagation. Can I do it without the thing? Did that work? I actually don't know how that works without. And then it's just wrong. How do I do it? Because the thing is that this could be marked twice, right? And then this could be flipped twice. And then that's just like really weird. So for the subtree it could work. How do you propagate it down? Down. I have to, oh, I see. I have to do it the other way. Okay, I got it. Okay, I think I got it. Okay, and then basically, actually you can do it the other way, really. Something like this. No, it's still the wrong answer though. I was hoping that this would, if I do it twice, then this would be flipped, but let's try it this way. I don't know. Oh, no. That's right. What I need to do is that if this is the case, then we need to update. How do you get to I? How do you get to count for the individual subtrees? It's these things, but then we have to do this other flippy thing, right? I don't know. Because these are not, basically this is just saying that these are flipped. So that when you do the count, you're able to do it. Maybe I need push to have. I don't know if this fixes it, to be honest. The time, if it times out, I'm going to the doctor's. I don't have time to do anything more. Okay, well, I don't know how to do it with this thing, and maybe that's fine. But it's a little bit sad because I mean, maybe it is way possible that there's a cleaner way to do it, but truth is, I just have to go to the doctor. So like, you know, so it doesn't matter. And this gives me a different answer, and I don't even know which one is more right. To be honest, well, this is more wrong. So. Yeah, this one is slightly more right, but this is wrong here. So I don't know. There's a lot of off by ones. I don't even know if they were actually off by ones, to be honest. Because it just may be a deeper misunderstanding, right? It's not necessarily that, and this is the right answer. So. But so it's like either one or the other, and I don't think I'm doing it quite right with the propagation the way that I'm doing it. I need to propagate down to XOR, and I'm actually happy that I figured this part out. But I don't know. I have to start going to the doctor soon. Are people getting it? A lot of people are getting it. So maybe there's a simpler solution, and I'm just stuck on this particular part. Yeah, I don't know. I mean, it is just like a lot of segmenty things, and then maybe it can be do with binary index tree. Let me see if I could give it a good attempt. No, I don't know. I think it's the same idea or same issue that I'm running into now, or will be, because the binary index tree is a little bit weird with respect to XOR, at least the way that I'm thinking about it. At least for range ones. You want range and then some, right, which is... Maybe it's not sig tree. Maybe I'm just overthinking this one. A lot of people are getting it though, and I'm not even that close. I have to go in about 10 minutes. Also curious about the timing. Oh, they don't tell you the time if it's wrong. Okay, I actually didn't know that. I think I'm covered here though. I think I'm pretty happy about this, but I don't know how to do the propagation part in a clean way. I'm just reading up on binary index tree, maybe seeing some inspiration. Oh, wait, did I just mess this up with a typo? I did. Time limit exceeded. Okay. Oh well. That's actually pretty bad typo. I mean, I still got a wrong answer, but okay. So I'm happy with what I have. I don't know what the issue is because there's a hidden case, unfortunately. Did they tell you at all? That's pretty bad, actually. But I'm happy that is this true? I feel like maybe this is hidden test cases. I don't know. Who knows? Maybe that fixes it. A lot of possible issues. Oh my god, I hate you. But I mean, Yeah, I mean, I'm very happy that I got it. Obviously, four wrong answers sad, but I actually had the idea immediately, right? It's just that I didn't know how to do the seg tree part. So, um, so I think at the end of the day, if it's about learning, then and I'm very proud of this, because it's all about learning, and even with the yeah, and I think I had enough of doubts to not believe in my code, which is why um, like I should have, like, obviously this debug I should have fixed, and these two as well. I just didn't really think about it line to line on this thing. I think what I did was I copied and pasted the code mentally, and just like tree code mentally, and didn't really think about what it means, right? Um, yeah, I mean, maybe I mean there probably is a easier solution, uh, but whenever you figure out and learn something, I mean, this is how you really learn something, right? I mean, obviously, maybe ideally you learn it outside of contest, but yeah, I'm pretty happy that I got this the way that I did it, and I almost in a forced way. I was forced to do this. I was forced to kind of to be honest, learn for the first time. I don't think I've ever done lazy propagation in my life. I kind of understood I mean, I hear the word and I understand the concept, but I never done it in my life. So I think I'm pretty proud about how I did this. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and the explanation and everything. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.